Question 12, what we want to do is to find the coordinates of the points A, B and C. To find the x-intercepts, we set y equal to 0, x squared minus 3x minus 4 equals 0. So we can say that the point A has coordinates minus 1, 0, and B has coordinates 4, 0. To find the y-intercept, we set x equal to 0 in the equation, so y then equals 0 squared minus 3 times 0 minus 4, and that's minus 4, and the coordinates of C then are 0, minus 4. Part B, the x-intercepts occur when y equals 0, so we have x squared plus 6x plus 9 equals 0. X plus 3 equals 0. Both brackets give the same answer. We only need to write the answer once. The coordinates of E then are minus 3, 0. The y-intercept occurs when x equals 0. So y equals 0 squared plus 6, 0 plus 9. The coordinates of the point D then are 0, 9. Part C, the x-intercepts occur when y equals 0. So 24 minus 2x minus x squared equals 0. We don't need to turn the equation round, we can factorise it as it is. X and x, now we want the factors of 24, which will give us a 2 if we add or subtract, so 24 and 1, 12 and 2, 8 and 3 and 6 and 4. 6 and 4. We want to get a minus 2, so I'm going to minus 2x, I'm going to put the minus here and the plus here. 6 plus x equals 0, 4 minus x equals 0, x equals minus 6, and x equals 4. So F has coordinates minus 6, 0, and G has coordinates 4, 0. The y-intercept occurs when x is 0, and y then equals 24 minus 2 times 0 minus 0 squared, that's 24. So the point H has coordinates 0, 24. Now, we've already worked out that this is graph A again, so this point is minus 1, 0, and this is 4, 0. What we want to do now is to work out the coordinates of the turning point and the equation of the axis of symmetry. So I want to work out the equation of this line here. Axis of symmetry then. We can find that by adding the two roots together, so minus 1 plus 4, and then dividing by 2, that gives 3 over 2. So the equation of the axis of symmetry is x equals 3 over 2. We want to work out this point here. Well, we know it lies on the line with the equation x equals 3 over 2. So what we'll do is we'll substitute x equals 3 over 2 into this equation. And that gives 3 over 2 squared minus 3 times 3 over 2 minus 4, 9 over 4 minus 9 over 2 minus 4. And we convert all these to a fraction over 4. Multiply top and bottom by 2. Multiply top and bottom by 4. That's minus 25 over 4. So the minimum turning point occurs at 3 over 2 minus 25 over 4. Part B, so we found that the root was x equals minus 3. This is the equation of the axis of symmetry, and we don't need to do a calculation here because this point, the coordinates of this point, the turning point, can be read off the graph. So the minimum turning point then is found at x equals minus 3 and y equals 0. Part C, the axis of symmetry is found by adding the two roots together and dividing by 2. That's minus 2 over 2, which is minus 1. X equals minus 1. Somewhere around about here. Want to work out this value here, so we're going to substitute x equals minus 1 into this equation. 24 minus 2 times minus 1 minus minus 1 squared. 24 plus 2 minus 1 is 25. So the coordinates of the turning point, and in this case it's a maximum turning point, are found at minus 1, 25. Question 13, we're told that we have a general formula, y equals kx squared is the equation of this graph, and we want to work out the value of k. There's only one point on the graph that we know apart from 0, 0, which doesn't help us much. So y is 3 and x is 1. So we substitute in the x and y values. 1 squared is 1 and 1 times k is k. So k has the value 3. And the equation then is y equals 3x squared. I'll do exactly the same thing here. We have an x value of 2 and a y value of minus 8. Minus 8 equals k times 2 squared. 2 squared is 4, so we have 4k on the right hand side. If I divide by 4, minus 8 over 4 equals k, and k then equals minus 2. So the equation of this curve is minus y equals minus 2x squared. And we shouldn't be surprised by the negative because this is a cap-shaped graph, or sad face. Now this one's a little bit different. We're going to use the formula y equals bracket x minus a all squared plus b squared. You can see this graph has been moved right 4 spaces and up 2 spaces, because this point here, the minimum turning point, would originally have been at 0, 0. Now, what do we do if the graph has been moved 4 spaces to the right? Well, what that means is that the value in the bracket is a minus. So we've got bracket x minus 4 all squared, and if we have an upward move of 2, then we have a plus 2 here. Y equals x squared minus 3. We could very quickly make a sketch of this. Here's the x-axis and here's the y-axis. Now, here is the graph of y equals x squared. And what is the effect of the minus 3 at the end? The minus 3 at the end moves the graph down 3 spaces. So we have the same shape, but we move down 3 spaces. Right, so it asks us whether it's a maximum or a minimum. Well, it's a happy face because it's a positive x squared, so it's a minimum. We could also state the turning point. It's at 0 minus 3. The axis of symmetry is this line here, which is the y-axis, x equals 0. Now, the x plus 4 means that the graph is moving 4 spaces in this direction, and the plus 2 at the end means the graph is moving 2 spaces up. So 4 spaces left and 2 spaces up. It's a happy face because we've got no negative at the front. So here is the original y equals x squared. What I want to do is to move that 4 spaces to the left and 2 spaces up, so approximately here. And I can draw in a full curve, full line. This is the point minus 4, 2. The graph was originally at 0, 0, and it's been moved 4 spaces left and 2 spaces up. So it's a minimum, and the turning point is at minus 4, 2. The axis of symmetry is just this value here. X equals minus 4. Final part. Now, this negative here means that the graph is sad face. The x minus 2 in brackets means that the graph has been moved 2 spaces right, and the minus 5 at the end means the graph has been moved 5 spaces down. So 2 spaces to the right and 5 spaces down, that's 2 minus 5, and we want a sad face, so it looks something like this. It's a maximum turning point located at 2 minus 5, and the axis of symmetry is this value here, which is to say x equals 2.